Hi, everybody. We are going to be solving mixed functions. So let's look at this guy. Cosine squared x times cotangent of x is equal to 2 times the cotangent of x. This is a weird one because we have two different trig functions, right? We have cosine and cotangent. So with this question, I think what I'm going to do is start by setting it equal to 0 and see what happens. So I'm going to sort my terms. So that way everything, that doesn't really help. Everything is on the left-hand side of the equal sign. I'm looking here and I see a GCF of cotangent of x. So I'm going to go ahead and factor that guy out. And I'll get cosine squared x minus 2 equals 0. Okay, zero product rule says that I can set each binomial equal to 0 to solve for x. So let's set cotangent of x equals 0 and cosine squared x minus 2 equals 0. With cotangent of x equals 0, let's remember our reciprocal identities. You know what? Let's not solve this one first. Let's solve this one first. This is easy and not new, so it'll just be a nice little review. Okay. So with cosine squared x minus 2 equals 0, let's go ahead and add a 2 to both sides. I would like to isolate the cosine of x. So I've got cosine squared x equals 2. I'm going to square root both sides. Remember, because this can really be rewritten as that, right? Don't get confused, though. So I've got the cosine of x equals plus or minus rad 2. I want you to think about the graph of cosine. The graph of cosine. It goes from -1 to 1 in its range, right? So if I were to graph this guy, do a little sketchy poo. Oops, that's too far over. Come on, sketchy poo. All right, there we go. Pi, 3 pi over 2, and 2 pi, right? If I graph this guy, we start at the maximum, passes through 0, minimum, passes through 0, maximum. Go ahead and connect it. Now, this only goes from -1 to 1. So anything that's greater than 1, the square root of 2 is greater than 1, or less than -1, the negative square root of 2 is less than 1, -1. We are going to reject it because it's out of range. So we would write reject out of range. Okay. The range of cosine is from -1 to 1. Okay. So for the cotangent of x, right, let's remember our reciprocal identities, right? We can rewrite the sine of, we can rewrite secant of x as 1 over the cosine of x. We can rewrite cosecant of x as 1 over the sine of x. And we can rewrite cotangent of x as 1 over the tangent of x, right? These are our reciprocal identities. So for cotangent, we want to envision 1 over the tangent of x. So we can rewrite this equation, right? Envision this as over 1. We can rewrite this, because it's a reciprocal, as 1 over 0 for the tangent of x. That would be its reciprocal. But what does it mean when we have a 0 in the denominator? That means that the tangent of x will be undefined. So we're trying to find on the graph of tangent where it's undefined. But remember that tangent is sine of x over the cosine of x, right? So the tangent is sine of x over the cosine of x. Or let's not use the whole word. Tangent of x is equal to sine of x over cosine of x. So if we imagine it a denominator of 0, I'm looking for where the cosine of x equals 0. That's what I'm looking for. I'm looking for that. Okay. And that will give you where tangent is undefined. And the reason for thinking of it this way is because I don't really store the graph of the tangent of x in my brain. I mean, like, I have an idea what it looks like, right? We're going to have vertical asymptotes at pi over 2 and every repeating increment of pi over 2 after that. But it's sine and cosines are really in my brain, right? Those are just like drilled in there. So it's actually already drawn over here, the cosine graph, right? And we're just looking for the values where cosine of x is 0, and that's going to be at pi over 2 and 3 pi over 2. So when cosine of x is equal to 0, that's when my tangent is going to be undefined. So my x value for the angle would be pi over 2 and 3 pi over 2. These are my two answers. Yeah.